Hi, I'm Alan Ross. I'm here at the IEEE PES T&D, that's a lot of acronyms, conference. This is the 2020 version that is actually being held in 2022. These interviews that we're conducting is with thought leaders on the future of the power industry. So enjoy. Our next guest is Leon White. He's a dear friend. He is in charge of transformer product development, business development globally for H2 Scan. Leon, it is great to sit here with you. Now, that's not his real title, but guess what? That's what I want your title to be, because you don't sell transformers. You sell things that make transformers better.
There you go.
Leon, the future, there's a lot of change going on within the utility industry, the power industry as a whole. So as a visionary, I'm going to ask you to put on your visionary hat. You're not an H2 Scan now guy, you're a guru. What changes do you see taking place? I really do value your perspective. You probably talk to more customers in a week than most people talk to in a year, literally. Mm-hmm. So you hear a lot of the problems, you hear a lot of the issues that they're dealing with. So talk to me a little bit about it from your perspective.
So I've been on the utility side. I worked for a utility for a number of years and have been on the sales side for a number of years, and sold lots of different kinds of online transformer monitoring. And what I've learned is that in the end, customers want simple, reliable monitors. And having sensors that last a long time and monitors that last a long time that they can count on to give them good information, that's really all they want. And so being an H2 Scan, I get to work with a lot of different vendors globally on hydrogen monitoring, and we have a great name in the industry.
So I know the dirty little secret that I'm not even allowed to dispose of, but see, I don't get paid by you guys or anybody else. H2 Scan is in a lot of these brand name monitors. H2 Scan, I actually brought into a company that I brought you in as a vendor in the company that I worked in because of the quality, because of the consistency. H2 Scan is ubiquitous in the industry as a hydrogen monitor. When you say accurate and cost effective and all of those other things, that's what H2 Scan is. But when you look at the industry, there's a bigger problem, and that is data. There's this now push that everybody's got to figure out how to use data that comes from these monitors that you guys create, and you create them for other people, so you don't really control where that data goes, right? So from that perspective, data being one of the problems that we're trying to deal with, what is H2 Scan doing about that? What does it look like for the future?
So we have a very bright future. There are a lot of things going on with hydrogen, from electrolyzers and fuel cells to hydrogen and natural gas pipelines. We are working on solutions to move our customers forward. We have a lot of interest, not only from existing customers who install our sensors inside their products. A lot of people are asking for more of the solutions, so we're looking for people to partner with on communication solutions, software solutions, and be able to provide more complete solutions to our customers.
Transformer monitoring in transmission and generation, that's been there. And you've been around that world for a long time. Why is it now that you think we can possibly get to the point, and I do think it's H2 Scan that's going to get us there, why can you get to the point that we can think about putting hydrogen monitors, battery operated hydrogen, will they have communication capability?
Of course, you have to get the data.
And exactly, on pole mount transformers, distribution transformers, pad mount transformers, because that's the next problem, is the whole grid is changing. And all of the change is happening, for the most part, at the distribution level with, transportation and with distributed energy resources management. All of that is bringing about an enormous amount of change. And so, consequently, what is it that's going to allow this revolution?
So in the past, utilities, 30 years ago, didn't even think about putting a monitor on their transformer.
Right.
And as they realized that there were new innovations and different things they could monitor on their transformers, monitoring became a staple on large transformers.
Right.
And now most utilities aren't going to buy a large transformer without some amount of online monitoring capability, and that always involves communications. So in those substations, you have communications to bring the data back. Now people are moving to middle-sized transformers and adding some amount of monitoring to those. And so it's a natural progression as lower-cost sensors and more reliable sensors are installed and available in the market. You can reach these lower and lower levels. I've found that it's distribution engineers sometimes don't even know what a DGA is.
Yeah.
And so I had to explain to a distribution engineer recently that the DGA stood for dissolved gas analysis, and you take an oil sample from a transformer, but I found out, I was educated that transformers outside of a substation, utilities don't take online or don't take DGA samples. They don't take oil samples on those normally. And so as people are moving the monitoring to smaller and smaller assets, there's a lot of education that needs to be done in the industry about the value of monitoring those smaller assets. And now that utilities are installing communication networks across their networks for metering or distribution automation, now there's a communication medium that can be used to bring the data back.
That's excellent, because it moves us from reactive, hey, a transformer failed, you got an outage, now you got to go replace the transformer, to proactive, hey, we got a gassing problem, that's an indication of failure, let's go swap that thing out before, or let's route around it and not even have an outage for the most part, because that's what all of this new relay system and the self-healing grid is bringing about, the ability to take a transformer out of service and put a new one in, not reactively, but proactively, and monitoring is the thing that's going to allow people to do that. They get measured, utilities get measured for every millisecond that they give an outage, right? So they don't like outages, and of any sort. And outages because you've got the number one, I think the number one reason beyond weather events is when you lose branches, I mean foliage. I mean, you get so much when you talk about foliage that it just, trees grow and the wind blows and the branch falls off and the line drops and the transformer pops. It's kind of like this sequence, right?
Yep.
Now, we can't prevent that, but at the same time, if it's about a transformer before it has that kind of a foliage thing, you can take the weak transformer that might actually survive the line break. That's part of what's happening now. How do we survive line breaks, which creates the fault, which creates the current, which creates the problem? The overload, transformer fails. Now you got a different problem. You know, it's okay for a branch to knock a line, but the whole distribution network is wide open. It's like the Wild West to be able to build a reliable, resilient, meaning if you have a problem, it comes back quickly, efficient grid. That's what we're trying to do. So it's a great place to be in the world where you're going to start monitoring those. You also have another part of the company that you're the transformer part of the company, the component, the sales part of the monitors for transformers. You have a process and safety side. As the president of the Electric Power Reliability Alliance, I wish I'd call it the Electric Safety and Reliability Alliance, because safety is a big issue. So when you look at the idea for H2 Scan, I know we're going to be talking to your COO, soon to be CEO, Dave Myers, but from your perspective, the potential that H2 Scan's got because of the process and safety side of that, what are your thoughts about what's going to be happening there?
Right, so a number of applications are opening up right now with what's called the hydrogen economy, and from electrolyzers that are going to generate hydrogen from water to electric fuel cells, hydrogen fuel cells, to putting hydrogen in natural gas pipelines. And today there's a lot of hydrogen sensors on the market. Many of them don't last very long. Many of them are sensitive to other things in the gas stream or in the environment, and so there's false alarms. And so Our sensors being hydrogen specific are ideal for a lot of those applications. And if you think about it, if you replace natural gas, which is methane, with hydrogen in natural gas pipelines, now they become hydrogen pipelines, and people will need to replace their carbon monoxide detectors in their homes with a hydrogen detector.
Yeah.
So investors understand this, and they have recently invested a lot of money in H2 scans so that we can develop new technologies, lower power technologies. Today, it's difficult to power our sensors with batteries, so we want to be able to have low power, smaller sensors. Eventually, we want to have wearable devices, so people walking around with compressed hydrogen will be able to know if there's a hydrogen leak, if ID or something might beep if there's or have a red light if they sense hydrogen where they're walking.
Or maybe a little shock that they go,
there you go.
They get
there you
ready
go.
for that one.
Or a picture of Alan Ross.
That would be great. Anyway, Leon, thank you for joining us. I appreciate it very much. Much success in the future.
All righty. Thank you, Alan.
All right.
Good to be here.